Remind me and we'll check it when we go to grade the other one. All right, kiddos, just joining us. I think everyone's here today, but just in case you're checking into the video later. We're working on this example in the back of our homework spiral. Now, guys, why am I, well, maybe this isn't a good thing for me to show you. I was going to show you something, but hold on. Maybe I'm not. Well, I was going to go to the calculator and talk about the decimals, because remember we talked about yesterday how the test isn't going to have a lot of decimals, but you could use them to your advantage. But if you have to plug in every single multiple choice into your calculator, how much time that's going to take. But to be honest, we don't even have a decimal for this question yet, because we don't even have x alone, right? So it's not so much about making it pretty right now, it's about actually making, well, I should say actually solving. So what's the very first thing that you guys would do? Subtract, and then? Divide, and what do you get by itself?
X, or L and X.
Okay, so subtracting 2, you get 10. Dividing by 3, you get something nasty.
10 over 3.
Okay.
I saw myself in this movie.
Where's up to the country?
Here?
Yeah.
Here?
I came here like super early, like at 7:20.
Where?
My mom was talking to me for breakfast, so hashtag blessed.
So we subtract 2. I know, guys, Laurel needed to take a test and she changed her mind, something about her schedule. So hold on, let's keep going. We have ln of x is equal to 10/3. By the way, Jaden, we thinking we need to have like a deadline by you for you to take your test.
For what?
For you to take your test.
For which test?
Or
You missed at the very beginning.
I don't remember.
You missed for a doctor's appointment, chapter
No,
2.
yeah. But I don't remember any of chapter 2.
That's why we need to figure
No,
out.
I got nothing.
That's why we need to figure out a deadline.
Okay. Then can you teach it?
There technically is a cubed root of e to the 10. That would be another way of writing it. And there technically could be another way of writing it, because this is e to the full 3 and then the cubed root of 3. We would do that
Is
too.
the first one fine?
But, yeah.
Wait, how would that equal the bottom row?
Because, remember, if we're trying to simplify radicals, we pull out things like square root of 8 becomes 2 root 2, because this has a square root of 4 and a square root of 2. That's kind of what's happening here, because another way of looking at this without saying, oh, it's 4 and 2 and 4 has a square root, you could also look at it as 2 to the 3 halves, which is 2 to the 1 and a half, which is 2 and a square root of 2. But anyway, there's lots of different ways of looking at it. But here's the nice thing. Kiddos, on the test. Sophia and Alec, I need you to be quiet today, okay? I have e to the 10/3 and I have e to the 10th cubed rooted. I have both of these, but what would be true about their decimals if we were to plug them into a calculator? If they'd be the exact same. Because they're equal, because they're equivalent, because they're both answers. So therefore, all that to say, if on a test you have an answer and it doesn't match the perfect form of one that's down there, you can technically plug in, make sure their decimals match, and then make the match. Sound good? Okay. But this isn't really the place where we need to be careful of that. Remember, yesterday, the place we really need to be careful of that is with LNs. And all of that is because, coming back to, I think, the very first page of, I think, 3.3, which is weird because that's back a ways, we were reminded, nope, that's 3.4, 3.3, we were reminded that the change of base formula was a pretty important one. And so even though we're not lazy, it's not so much we're lazy, just this seems easier to use sometimes, like a log base 2 or a log base 4. Remember, because of its prevalence in scientific and mathematical communities, and in just like the different operations, operations, I should say, topics involved, the book is always going to prefer, almost always going to prefer, using LN notation over the other base, like a 2 or a 5 or a 7. So that's why we have to be really careful when we grade homework today, because some of your answers are going to look like this, but the book's going to write it like this. But what's important is that your calculator would show that the decimals match. It's just going to save you time on the test if you don't have to go looking for decimals every single time. Okay, let's go grade. You guys said we never got to grade section 3.2. So we'll go back to that one, but if you guys don't mind, can we grade 3.4 because it's fresh in our minds? We did it last night. It's theoretically like the questions that you have, you should be able to remember, etc. Section 3.4, let's start there. Let's grade this first. It's what's freshest in our mind. And then we'll work our way backwards. So 3.4, number 2. Oh, we didn't really see this yesterday. I've mentioned it about how sometimes you might have illegal answers, and we're going to see if you found any illegal answers in homework. The math said yes, but the book said no. Those are called extraneous. Something where the math gets us to an answer, but it's illegal. Huh. Anyway, number 2, extraneous. Number 12. Yes, it's 0.01, but 1 over 100 or 10 to the negative 2 was the best way. 1 over 100 or 10 to the negative 2 were better answers, but either way, 0.01. Number 16, the point of intersection, you would have set them equal to each other. And you needed, how did you guys go from here to here? Can you tell in your notes? Did you do the snail? Did you do the rewriting? Or did you do 3 to the power of 3 to the power of? Good, good. I like the 3 to the power of because you're understanding how to undo a log. Good. But the snail works too. Anyway, x is 9, and so 9, 2 is the point of intersection using that y they gave us. But x is 9, so the point is 9, 2. Number 24. Now, here's the beginning of where it starts to get funny. Couldn't you have done log base 4 of both sides? Yeah, totally, and you would have been right. But what did the book do? Because they are going to prefer it every time, ln. And the reason they did ln when you bring down and when you solve is because then you get this ln notation. Now hold on. What's the other way this could have appeared or could have looked?
The log.
Yeah, you could have had negative 3t is equal to log base 4 of 0. Did anybody get that?
That's what I did.
And you're not wrong. But check it. Wouldn't change of base formula have gotten you right where they got without doing the work? It's up to you. You can do log base 4, and without having to use a calculator and go checking every single answer, you can look for the change of base. Now, wait. You would have had to divide by negative 3, right? But if you notice, their answer has a divide by negative 3 also. They just changed the form with the change of base formula. So, you could solve the way they're solving. Use ln's instead of log base 4s. Or, you can get down to something like this. If you don't just want to plug everything into your calculator and make it match, you could go ahead and, at this point, use the change of base formula to get exactly where they go. But why are they showing the decimal? Because if you plug this in, you would have also been right, and it would have been 0.55. So guys, on the rest of homework, pause. Could your answers look differently than their answers? Yes. So what's the thing that you should be checking? The decimal. Does that make sense? Okay.
Do you want us to write the decimal?
No, I mean, if you see it and it matches, just stop. You're good. But the decimal is just letting you know that it is like an option and it is out there as far as you could be getting answers in different forms. And that's how they should play. But if you can't tell whether or not yours matches, write the decimal and the next. Does that make sense? Yeah. I don't know, but right now we're being 3.4, that's where we're at. And then we're going to go back.
Probably the more.
That's why we're so off. I know people were absent, and I think on Friday in the video I mentioned you were going to grade on Monday, and you probably just Number 30, you doing okay? Number 36, you can't quite see the answer, but it's there. You can still see number, whatever it was, number 30. And might be able to leave that decimal before you can almost get done. Hey, inverse property. Hey, the ln wasn't a bad idea here either, because ln of e, it canceled out one side, we were just stuck over here. But remember, if you have different bases, there's no perfect way anyway. You're going to have to use this product property somewhere. Sorry, power number. E to the 10th plus 8. Once again, kind of answering Emily's question, but guys, the decimal is only there for you to help make it match. This is the preferred answer, e to the 10th plus 8. It's definitely the preferred answer. I'm seeing if we had more, we do. We got it? It's on the next page. I just didn't want to scroll before people were ready. Are we okay? Oof! Oh, extraneous. Did you guys find any extraneous ones in the odds? Any ones where your math told you, hey, either one is good, and then all of a sudden in the final answer they said, no. Here's the dealio. When if you were able to condense, and then use the one-to-one property, that's probably the easiest way to go. Or if you did 2 to the power of both sides, either way, the logs got ignored, right? Whether you did 2 to the power of and actually got rid of them, or whether you did the one-to-one property, you ignored the logs to get here. The problem with ignoring logs is you're ignoring their domain restrictions. Back here at the very, 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 very beginning, if we were looking at the domain of this entire thing, we would have to look at every single argument and say, okay, what x's work in every single one? The first one, x has to be greater than 0. Because remember, 0 is my vertical asymptote. The second one, x has to be greater than -2. The third one, x has to be greater than -6. So if I'm looking at a number line, in order to work in every single one, which one do I choose for my domain? Greater than which one? No, because then, well wait, greater than 0, that means 1, 2, 3, 4. Oh, that would be greater than and greater than. If I chose this one, wouldn't -5 not work, right? Wouldn't -4 not work? If I had chose this one, -1 wouldn't work. Yeah, good. So if that's my domain of my entire function, the x's that would make all 3 of these work, then question, why is -3 extraneous? When ignoring the logs, an illegal x snuck in. He's not allowed to be included. Mathematically, if I ignore the logs, he's fine. You're right. It does make those two equal. But the problem is the -3 wouldn't have been allowed at the beginning because it would have made some of those expressions D and E. Would have made them not exist. So this word extraneous that you guys had in your vocab for number 2, it's super important because it says, yes, solve, but after solving, and you might want to write this in a pen either in your notes or right here in your homework. I guess the but, it doesn't really work now. After solving, you need to check for extraneous. Only in logarithms. The nice thing is exponential functions, their domain's all real numbers, so everybody's allowed. I'm fine. But for logarithms, after solving, check for extraneous solutions. And what that means, check the... Extraneous solutions are ones that the math said is okay, but that is outside the domain, aka that RLB. Does that make sense, kind of? Okay. The math said, oh yeah, we don't care, -3, because the logs went away. But then we're like, no, but the logs were there to begin with. Hold on, wait, double check. Oh, never mind. Only choose 2. Number 78, I think you just end up with E. 78, you end up with E because you multiply the x squared on the other side. That was this little step. Some of you might not have known how. Multiply it. 0 times anything is 0. Subtract the 1. Divide by a negative. E to the, boom. Is that the last one? Oh, no. 84. You guys had 84?
Yeah.
84, they just said set P equal to 169. Now this might seem totally crazy and totally out there, but here's what's going on. This is like in science labs or in higher math classes. This could be a problem that you have to solve. You might not understand all of the why or the what or where the formula came from, but it's a formula you could have to solve. I mean, we've learned with area formulas and volume formulas, you have to be able to plug and chug, but also rearrange to solve for like the lengths or the widths given the area. That's what this kind of is. So they're saying, okay, what if the population is 169 for this logistic growth? What? Don't worry. You don't need to know what this is. Just could you do the math? Would you know to divide the 5,000? Would you know to subtract the 1 and divide by a negative? Would you know to multiply this guy up on the other side and then divide this coefficient on that side? Would you know to subtract the 4, take ln of both sides, and then do a final division? Whew! Could you get to the variable that you needed to solve? It's pre-calc. It's knowing basically how to carefully break apart a problem and use algebra to rearrange it, and eventually how to undo it e with an ln. So the final answer is 983-ish. They rounded to the nearest whole phone, because a decimal phone doesn't really make sense. So don't stress too much as to exactly why this problem was as nasty as it was in the beginning. Just think, okay, could I rearrange it and solve for what they needed? That's it. Wait, was there just an A? No, there had to be more. Oh, stink. What was B? Was it like a 299? Use the model to... Oh, this one's... Oh, no, that's not... What number is this?
84.
Oh, 84. I'm looking at 86. Lo siento. Here we go. Oh, you're doing the exact same thing just with 299. Sorry, guys. I didn't copy it. Did you guys... What did you get for the number of phones if you got A right? 795. Anybody else get 795? 685? 685? Oh, I think 685 is the one to go. Double check. Something probably little went wrong. Okay, guys. I want us to stay on 3.4 for a second longer if we need to answer any questions. Are there any odds or even extraneous, didn't know how to get to the answer, calc chat jumps that were confusing? Priyanka. 57. Megan? 36. Anything else? Yeah. 55.
That's a Van Halen reference.
That's it?
Yeah, only 55.
Just 55.
No, something that runs in those.
Alright, let's start with 36, then 55, then 57. Alec, thanks for the reference. Sorry, most of us don't understand, but I appreciate it, because whenever I hear 76, I always think of a song too. But it's a song that almost no one knows anymore, so. It's from the musical The Music Man, and it's called 76 Trombones. 76 Trombones. If you know musicals or Broadways, you might be good, but otherwise. So my brain's always like, but I never say anything, because no one ever cares. Number 36 was the first weird one. Why is it weird? Just tell me why people don't like it, because it's true.
Because there's an E and a 2.
There's an E and a 2, but that's okay. Because if we follow the book's way, we don't have to have the log base 2 fix everything, or the ln fix everything. All we need is a log. And if we follow the book's way, they'll say, oh, use the natural guy, use the normal guy, use the guy who's used all the time. Now, he's really good on the right-hand side, because what happens with ln and e?
Good.
They're inverses, so we get 1 minus x. But what happens on this side? Nothing until we use the power property. Now, do I want to divide the ln2 right now? Because see this little x, wouldn't he be trapped in a division? So if I'm not dividing him, what do you guys think I'm going to do? What else is there? You might not like it, but it's the way to go. Now, why wouldn't I write it ln of 2? Alec, this was your question yesterday.
Yep.
Why wouldn't I write it ln of 2x? Why can't I write it like that?
Because it's just ln of 2.
Yeah, it's just the ln of 2 times, so I need to put the x in front, right? Plus ln of 2. Okay, help me out. How's the algebra work at this point? Get the x's on one side and get the numbers on the other, right? So does it make sense? I'm going to get the x ln 2. Move that guy to be with the other x guy. Yeah? Okay, what can I do with this x? Factor it out. Now, hold on. This is a little dangerous, right? Where I just wrote ln of 2 plus 1, but do you guys understand what I mean by it? I don't mean ln of 3, right? I mean literally ln of 2 plus 1. A better way of writing it would be 1 plus ln of 2. What's the last thing I need to do? Divide. 1 minus ln of 2. Now I'm going to write it the nice way so it's not confusing anymore. Now, if you're like, hey, the 1's go, the ln's of 2 go, and I have a minus over a plus. Ta-da! Makes no sense. Box it. You're done. No simplifying. Unless you want to take it to your calculator and check the decimal, but that is an accurate answer. 36, check. The other two are odds. You've been able to try them. Check at the back of the book. Use CalChat, and you've still gotten stuck. Let's see what's confusing with number 55. When I see number 55, the first thing I see where I'm like, oh, this is going to take a little bit of work, I see 2 different ln's. I see 2 different ln's. Can I show you guys something real fast that we did in pre-cal today? In pre-cal today, I was teaching them for the first time the log properties, or I guess we should say reviewing with them the log properties. You guys know the log properties, the product, the quotient, all of that jazz, right? But as we were doing the log properties for the first time, can I show you what I wrote in because of questions that we've had and things that we've seen? I wrote the whole single versus separate, but what's the green note I added in the pre-cal notes? If I want to get rid of a log, I don't want to do it with it all split up, because I'm going to make horrible mistakes because I'm going to forget these exponent properties as soon as I throw a base in. I'm going to forget that addition comes from multiplication, subtraction comes from addition. It's much better to get it as a single log first and then try to undo. And why am I showing you that with this question? Guys, see how I have separate ln's? Don't go doing e to the, because I can almost guarantee if you do e to the right now, you're going to forget that subtraction of exponents turns into division. You're going to make a mistake. It's a lot safer to combine it to be x over x plus 1 first. See it? Quotient property, subtraction. Then do my, wait, why am I throwing an e in there?
So you can get the whole log. Take the log of it.
Now, some of you are like, wait, I understood all of that. I didn't know what to do next. Well, I know some of you are like, let's just get rid of the x's, except then I have nothing to solve for, and it's illegal. And a kitten died. Man, 3 strikes, you're out. So if you can't divide, what's our only other option? Do what you can do. If you can't do anything here, move it. And if you move it, maybe something will work out. Sometimes you don't know exactly the path ahead. You just got to keep making the wisest steps that you can. Making legal steps in the process and see what happens. Now, some of you are still like, that didn't help. Forget it. I'm done. Pause. What else can you do? Simplify as many operations as possible. Just keep going. Follow the trail, even though you don't know exactly what it means. Well, why would I do that? No. As soon as here's why. If I take an ln, that x is trapped again. Remember, I need to get x by itself. If I take ln, the x is trapped and it's stuck.
Well, can't you just do 2e squared?
Well, I don't have a log though, so without a log, I can't bring it. I do want to factor, but in order to factor, I need to get all the x terms on one side. We just did that a second ago. We got all the x's on that side, all the numbers on the other to be able to factor out the, what's left? 1 minus.
After x equals e, there after that.
I saw that I have an x term here and an x term there. Whenever I have multiple x terms, I need to get all of them to the variable side. And the only way to move this is subtraction. So I would subtract it to the other side. Then I saw, hey, common x. Factor them out. Then divide away any non-x stuff. There's a lot to keep track of in this one. Really quickly, if you guys had thought of going the other direction and taking e to the power of both sides, can I show you how you would have ended up in the exact same place if you did it legally? And if you did it illegally, you're wrong, so it doesn't really make a difference. Your decimal's way off. If you thought e to the, there is a way to do this, but the way to do this is to pull out that exponent rule book and say, when I subtract exponents, legally, what does that mean? And what that means is a division of like bases. Subtraction is division. And so technically, you would end up at the exact same place. But only if you did it legally, and the likelihood of you doing this legally is very, very, very slim. Okay, so I'm like, let's just do the quotient property. Whoop! Alright, good. Still tricky, but at least it's legal from the beginning as opposed to very easily making some big mistakes. Yeah, it's okay.
Oh, well, no, I'm not going to
For this one?
Yeah.
But why?
Because
What did I not check for?
Extraneous.
Wait, but extraneous, hold on, that means something's illegal as far as the domain. Well, hold on, the domain is either x greater than 0 or x greater than -1, right?
Yeah.
Put them together. Okay, this is my domain. This is the guy who's safe for both. Well, this is fine because, wait a minute, this is a positive over a, who's e, approximately?
2.5.
2.5, 2.7-ish, but either way, what's going to be stronger, the positive 1 or the negative 2.5-ish squared? Oh, stinks. So 1 minus a bigger number, isn't that going to be a negative? And a positive over a negative is going to be a negative, and a negative is not. So it's not no solution because the math couldn't be done. It's no solution because this is less than 0, which means ding, 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 that fails. Thanks. Always check that extraneous, right? Oof. And we're on number 57, right? Oh, that's not the right one, sorry. I need the other PDF. He's right here. 57. So guys, based on what you just saw me do at the very beginning, going from here, I went this direction for your guys' sake. What do you think I'm going to do in number 57?
This side ln x minus 1 over x.
Yeah, that's called condensing, right? I'm going to condense using the quotient property. How's that look? Because what can I do now? What happens if I have one ln on either side? Called the 1, 2, 1. Where are you guys? You like this guy, the 1-to-1 property, right? If they match, I can just whoosh. Or e to the, ignore the ln's, cancel out the ln's. I know you don't like it, but come on.
I love that.
Tell me what to do next. Times. Wait, if I'm timesing, I better put those in parentheses. Binomials are getting multiplied. Now what? Times. Now what? Good, because in order to deal with a quadratic, don't we need it equal to 0 to be able to factor? Your factors were?
X minus 2x
X plus 2.
But then your zeros are. Okay, now what did we just see we needed to do whenever we have answers where LNs were originally there? Check. So, literally, you could think of what's the domain, or you could just plug in. -2 plus 5, is that a negative or a positive? Am I good or am I bad? Yeah, -2 plus 5, that's okay, that's a positive number. -2 minus 1. Just check it. X does have to be greater than -5 for that, but X has to be greater than 1 for that, and X has to be greater than negative. Stink. I need all my X's to be bigger than 1 to work for all three. Oof. So what does that mean? Extraneous, both of them. So any possible solutions are illegal, not included in the domain. So nope. There are no X's of or in LNs that could possibly make this true. Does that make sense? Good questions, guys. There were tricky things on all three of those. Different bases. X's all over the place with one extraneous. Oh, with both extraneous. And then actually this one had both extraneous also. Oh, the last one only had one answer. Okay, you guys, I need you to check. Did we really skip grading 3.2 and 3.3?
Yes.
We haven't graded since 3.1? Okay. Let's just keep grading tonight. Even though I said we were going to start section 3.5, we might just wait to start that until tomorrow. And a few of you guys that have gotten behind, we've had some extended absences, we've had some makeup work people. Maybe you can catch up a bit tonight. We did grade 3.1 though, right? The basic exponentially dudes? Okay. We did not grade the basic logarithmic dudes. Here we go, section 3.2. One big ol' assignment for us. Number 2 was 10. Number 8 was transforming the form, which this is the little guy that Joe Tan said was a snail. Because instead of taking 9 to the power of both sides, he said you could come. It's a way of remembering. You do 9 to the power of equals 1 over 81. Joseph Tan? Oh, Sam Tan's older brother.
Joe.
But you could have also done 9 to the power of it. Anyway, we have our changed form. We have our changed form. Making sure it works. Yeah, that works. We have our, wait, why is it 1/2? That was tricky. 5 is the square root of 25. And the square root is the 1/2 power of 25. Everybody's over here. 25 to what power is 5? 25 to the square root of, which is 1/2 power. I had some regular HPrecalc kids pretty confused on that stuff. Number 28 was a simple, oh hey, inverse property, 15. And number 38 matches with 15. Remember they show us all this extra stuff. Real quickly, because I know some of you might not have tracked of what I was saying. Remember that if I can make 5 equal to the square root of 25, I can take anything under a radical and change it to be a fractional exponent by taking whatever power it's raised to on the numerator, and whatever kind of root it is, square root is a, if it was a cubed root, a 3, a fourth root, a fourth, a fifth root, the square root is a 1/2 power. Anyway, you were able to change the 5 for a 25 to the 1/2. Log base 25 of 25 cancels 1/2 is left. We have some more evens though, right? 40 is another matching one. You get A. 50 is a plug and chug to your calculator. Negative 0.903. Oh, sorry, 58. You didn't actually 58?
No.
Oh, sorry. I said 50. Yeah, 58. Let's see, negative 0.903. Number 76 was a 1-to-1 property. Go team, but get it all to one side before you factor. You have to get a quadratic equal to 0. Any polynomial equal to 0. Otherwise, solving for zeros won't matter. Wait a minute. Were both of these good, or was anybody extraneous? 3 squared minus 3 is a positive. We're good. Negative 2 squared 4 minus negative 2 is 6. Oh, neither one was extraneous because both of them plugged in got us a positive number that ln says I don't know. There was a question. Izzy, was that you? 5. Section 3.5 will take us a couple days. I think our test was originally Friday, but now it's next Tuesday due to a couple different, like the fire and some minimum days. I think that's our last even, right? Okay, let's keep grading 3.3 just so we get everything all graded before the end of class. And then remember, in a way, tonight's kind of a catch-up night. For those of you guys with youth group, it can be not so much homework. Wow.
My YouTube's on Fridays.
It's not on the show. I don't go to and then you can always check out last year's video. Yeah, if you can see it. Because the notes won't be posted online. Number 4, C. Number 6, B. Oh, those are just matching properties. That's easy. Number 14, change a base. They didn't tell you what to change it to. So you could have changed it to anything, but why did they do these? Because these are the buttons in your calculator. These are the most common, awkward, he's common, he's natural, either way. The most common ones, but all of them should have gotten you this decimal. But guys, I would have gone to LNs because that's what we're having to practice, there to LNs. Number 16, it was expand, right? Pull it apart, pull it apart. Oh, this is nice because 4 is 2 squared. I can make that a non-log by just quick simplification. I can make that just a 4 because the 4 is a perfect power of 2. But this guy, 2 and 3, 3 is not a perfect power of 2, so we're stuck with them. So to leave them right there. When you expanded, there was some simplifying that could happen. But the other expression couldn't be simplified, so we stopped. This one, we can go ahead and split up. The ln of 6 is stuck. There is no e to the power of is a nice 6, no. Or e to a nice power of 6, no. But this one, I can go ahead, bring down the 2, ln of e is 1. Aha. Now, wait. Dangerous. Not wrong, because PEMDAS would say ln of only who's next to it, but what would be a much better way of writing that answer? Much better, much safer. 32, did you guys make the root into a fractional power? There it is. This one's a little bit easier, maybe. And then just bring it down and simplify. 46, expand. 54, expand. Oh. Lots of expanding. Did you guys make sure that both of those guys got the 1/2 power that came down? Both of them had the 1/2 power. Little baby puzzles. Using a lot of old math. 76. That one you're putting together. You had a product, you had a quotient, you had lots of little guys raised to lots of little powers. Anything else? Okay. Guys, let's kind of get on the same page. Sound good? We were supposed to start the final section of Chapter 3 today, and we didn't. And some of you might have questions on 3.2 and 3.3 that we just graded, right? So tonight, here's what I want you to do for beginning of class tomorrow. We haven't started 3.5 yet, and we haven't gone over questions at 3.2 and 3.3 yet. So 3.2 and 3.3. Look over tonight and narrow down questions that you really need to ask. Does that make sense? And have them ready, like as soon as I ask tomorrow, beginning of class, any questions on 3.2 and 3.3. We've already gone over 3.4. But then I'm also going to, let's say no. I'm going to take your notes, and Emily, this is partially for you, because she's going to be gone Friday. Any other cross country? Alec, you're going to be gone Friday, I think. Cassie?
No, I'm actually not.
You guys are all going to be here?
No, only me is going to be here.
Okay. But when we go into section 3 point, wherever he is, 3.5, he's here somewhere. There we go. I'm going to go ahead and save the notes tonight to include 3.5, which in some ways is like, okay, well, we haven't gone over them yet. But in some ways, it does have nice equations. Let me move this away from here so you guys can actually see it when I save it. And I'm going to save the notes that way. Oh, I have to change the setting. Awkward. Anyway, I'll go ahead and save the notes to include these important formulas that you might see coming up. Yes, they'll show up in actual section 3.5 as well. But tomorrow, okay, now here's a scary thing. You're like, oh my goodness, this section's going to be awful. Well, it's not so much awful as just, this looks like a homework problem we did, seeing if we can do the math to meet a certain goal. You don't have to memorize all these equations for the test or anything crazy. Just when you see them, do you know what to do? So anyway, those of you guys that might be trying to get ahead, I'll put the notes online if you want to have them ready. You don't have to for tomorrow. Narrow down 3-2 and 3-3 questions. Bye, guys. Narrow down 3-2 and 3-3 questions for beginning of class tomorrow. Let me try to get this off its setting.